Hello everyone, welcome back to BLDC Tech Hub. In today's video, we'll show you how to build a hybrid BLDC motor control system combining RS485 communication, PWM frequency modulation, and I/O switching for precise speed and direction control. Let's jump right in. To build this control system, here's what you'll need from BLDC.com. This system combines three control methods. The BLDC motor's speed is controlled using a PWM signal from an external generator, while the rotation direction and enable function are managed via I/O switching using a rocker switch. All communication and advanced configuration are handled through RS485, using a USB to RS485 converter and a PC running the BLDC control software. Let's go over the wiring step by step. Connect the 24-volt DC power source to the controller's power input terminals. Connect the BLDC motor's UVW 3-phase wires to the controller, and properly connect the Hall sensor pins if applicable. Connect the rocker switch to the controller's X1, X2 for enable and forward reverse direction control, and COM terminals. Power the generator with the DC supply. Connect PWM positive to the PWM input on the controller, and PWM negative to GND for speed control. Connect the RS485 converter to the controller's RS485 terminals, A for positive, B for negative, and plug the USB side into your PC. This enables software control over speed and parameters. Before proceeding, ensure the BLDC controller's RV terminal is off and set dip switches 1 and 2 to off. This preparation work is to lock out manual control and let the controller accept instructions via RS485 and I/O. Link the USB to RS485 converter to the motor controller's designated terminals. Double-check polarity to avoid communication errors. Connect the PWM signal generator to the controller's PWM port and GND, and wire the rocker switch to the controller's X1, X2, and COM for motor enable and direction control. To learn more about the rocker switch control principles, refer to our video on the I/O plus SV control of BLDC motor. Now power up the circuit and plug the converter into your PC's USB port. Let's configure the BLDC control software on your PC. Launch the software. Go to COM setting and click Connect to establish the connection. Once connected, you'll see COM Connect Success, and parameters will be read into the system. Parameters read to file success confirms the BLDC controller is now online via RS485. If connection fails, follow the prompts to verify the port and controller's address. Now let's go to parameter settings and configure the controller with the following parameters. Set PN14, the data channel, to 5 to use PWM frequency as the speed input signal. Set PN15, the control channel, to 1 to enable I/O switching as the control source. Set PN30 to 0 to define X1 as motor start-stop control. Set PN31 to 1 to assign direction control to X2. You can enable functions X3 and X4 if needed by setting them to the specified numbers. And you can set the maximum motor speed in PN002 under PWM control. The adjustable speed range is 300 to 6,000 RPM. For example, enter 3,000 in the new value field and click Write Parameter. The motor will now run up to 3,000 RPM. These settings create a hybrid control system with multiple command options. Let's see it in action. Toggle the rocker switch to position 1 to enable the motor. Activate the PWM signal generator. The motor begins to run at a speed proportional to the frequency input. Turn the knob on the signal generator to adjust the output PWM frequency and control motor speed dynamically. Note, the supported PWM frequency range for this controller is 1 to 10 kHz. If exceeded, the controller will trigger an over-frequency alarm via the LED indicator. Flip the rocker switch to position 2 to reverse the motor direction. Again, you can fine-tune the motor speed using the generator knob. And that's it. You're now ready to control your BLDC motor with this hybrid control system with RS485 communication for digital control, I/O switching for on-off and directional control, and PWM frequency for precise speed regulation.